Aloha and welcome. In this video, we're going to be talking about generic methods and type bounds. So let me go ahead and share our text with you. So we talked earlier about type parameters and how we can use type parameters to represent various user-defined types. But one of the problems we have is not all types support the same methods and operations. So for example, strings can't be subtracted and charat cannot be called on in an integer. So anyway, when you abstract this out, class types inherit their common functionality from the built-in object class. So when you're talking about string and integer, they inherit the toString and the equals methods from the object class. So what's going on in here is the Java compiler is internally replacing the type parameters like we created element type earlier. So it replaces that with object type at compile. So an instance of element type only supports the methods and operations that are going to be valid for the object class. So we call this type erasure. So type erasure is when the compiler replaces the type parameters with a common base type. So we're going to take a look at the participation activity here, and I'll explain it a little bit better. So when we start out here, we're looking at, it's going to come down here. It's going to go get LM index items and book. And remember, it's going to infer that the LM type here is string because of our the type of items and book. So we then go hit the next part. Oh, so what it's doing here is it's replacing LM type as string. So when you look at it, it's going to redo this at the compile time. It's going to rewrite this as string. So we're going to go ahead, run the next part. Then after that, it's going to do type erasure, and it's going to change lm type to object. So when we look in here, you'll see public static int get lm index object array, object lm. So it's actually erasing the type. So next step, the compiler requires that the methods call an instance of lm type are also valid for all objects. So here we've got equals, and that is equal. The string class overrides objects equal method to compare the string values. But in here, we can't do things like plus, like concatenation, things like that. It has to be valid for the objects. So there's certain things that will not work in here, but equals does, because equals is, part of the object class. So we'll go up here, run the next, and then you can see over here, given integers, it's going to infer the element type is integer when we're using this. It's going to say, okay, we're using integers. It's going to infer the type there. It's going to replace it with integer. Then it's going to do the type erasure, and it's going to change element type to object here as well. And then, as before, the integer class overrides the object's equal method to compare the integer values. So some of the common object class methods that are out there, equals is one of them. This is what I was telling you about, some of the ones that are common amongst them. So you can use these. Equals is one. So here you can see Boolean equals. It's going to return the Boolean equals. It's going to take an object of the other object. It's going to return true if the other object is equal to this object. And they give you an example here. The same thing for toString. It's going to be defined as string, toString. So it's just going to return a string representation of the object. And then hash code, and that's going to return an integer hash code for this object as well. So then we've got a participation activity here, and this is when you're going to get a little bit more familiar with what's valid, what's not valued. So determine if the given statement compiles. Assume the statement appears inside the process items method defined below. So we look here, public static type void process items type X, type Y, and we have our statements. So is type Z equals X plus Y going to compile or not compile? Well, as I mentioned up before, the plus is not something that's valid within the object. So I'm going to say does not compile. And yes, it says that Java's type erasure replaces type with object, so X plus Y does not compile. Go ahead and click on the other ones and see if it gives you any additional information as to why things would not be right, but it just kind of repeats the same thing here, that X plus Y does not compile. Then we've got Boolean have equals X equals Y. So this one, if you think about it, so we've got Boolean value for have equals X equals Y. So we know from up here that equals is a valid one. So we click on compiles and it says, yeah, Java's type erasure replaces type with object. So x equals y compiles and returns true if x and y are equal. Then let's see if it gives any other information. No, it's pretty much just the same thing. This is kind of straightforward. Then we have if x double equals y, you can go ahead and see that the program can use the double equals operator on instances of object. So it really comes down to what is valid using the object class. And then does not compile. It's not going to really give you any information extra there. It's just we're looking at binary things here. So string x is string equals x to string. So is to string also one of the common things? I believe so. So if we click on compiles, we'd be correct. So it supports the to-string method as we mentioned above. So there, nothing really new. Then string out print line for y object. And that's also going to compile because there is, that is supported for type object. So, yeah. So anyway, next we're going to be talking about bounded type parameters. So a programmer may want to restrict the types of the kind of types that can be used with a generic method. So we're going to use we're going to type bound them. So doing this restricts the types that can be used as type arguments for a single type parameter. So doing this with a type bound, it's called a bounded type parameter. So to declare a bounded type parameter, you follow the type parameter with the extends keyword and the type in bound. An example of that is going to be they use here coordinator type extends number. So after the extends is the class that you want to bound it with. So everything that is going to be legal is going to be legal upon number, anything that number can do. So anyway, looking at this, type bounds enable access to the class members of the class specified by the type bound. So for example, by bounding coordinate type to the number class, the programmer is able to invoke the number class's double value method with instances of coordinate type. So again, you're going to need to know what methods are valid on number itself. So we're going to take a look at the participation activity here. A type bound ensures a generic distance method is only called with numeric types. So if we look at this code real quick, we see public static coordinate type extends number. It's going to return a double. The method name is distance. It's going to take a coordinate type of, it's going to take an x and a y and a second x and a y. And then we're going to do a double, and that's going to be the diff x squared. So then we're going to do is the math power, and we're going to take in x double value. We're going to take the x, I guess, integer, change it to double. I get the double value of it, subtract the double value of the second coordinate x2. Then we're going to raise it, we're going to square it essentially. So then we do the same thing for the y's. And then we return the square root of the difference diff x squared plus diff y squared. So let's go ahead and run this demo. So we start out here and go ahead looking at this. The generic distance method returns the distance between the two coordinates. The number type bound requires the type arguments for a coordinate type inherit from number. So we're only going to be using functions that are valid for number. Or I say functions, I mean methods. So when we look at this, it infers the coordinate type is integer. But then over here, we're going to type erase coordinate type to number. And then once we've done that, you'll see that it's going to look like this. So we've got the return of double. We've got number, 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 number. The compiler internally is using type erasure to replace the coordinate type with the number bound. So then we go to the next step. So the next step, looking in here, the compiler requires that the method called on instances of coordinate types are also valid for numbers. So the things we have here are valid. The integer class overrides the number's double value method to return a double from an integer. And then the last step here, the type arguments for coordinate type must inherit from the number. Calling distance with string arguments results in a compiler error. So if you were to call this, these aren't going to be valid. So if they were just 1, 2, 3, and 4, you would be okay. But because these are strings, they're not going to be valid. So, all right. Continuing on, some of the common methods in the abstract number class. We've got double value, which we used above. That's going to return the number's value as a double. We've got float value, which is going to return the numbers value as a float. We've got int value, which is going to, as you think, return the numbers value as an int. And then we're going to look at using the number type bound. So in this participation activity, you're going to look through here and it says choose the correct statement to implement the calc average method below. So let's take a look at it. We've got static, type extends number, double calc average type x, type y, double average equals 0.0. Okay, good. So there's going to be statement A where we're going to declare a variable to hold the sum, statement B where we're going to compute the sum, and then statement C, compute the average. So when we're looking at the first one, we've got type sum equals 0.0 over here. No, that's not going to work because, again, it's going to be replaced using type erasure. So if you were to click on here, yeah, Java's type erasure replaces type with a number type bound. So yeah, number being an abstract class, so instantiating sum as a number fails to compute. Then we've got number sum equals 0.0. That's also going to give us a problem because some number is an abstract class, so instantiating the sum as a number fails to compile. So the last one is the one that it's going to be using double, and here it tells you that it's going to return double. So the intermediate sum must be a double. So calc average must convert parameters x and y to doubles before adding them and storing the results in sum. So that was easy enough. So now we're looking at the compute the sum. So we look at this, sum equals x plus y, sum equals x dot add y, and then we've got sum equals double value plus double value here. So we go back to looking at number. If we remember the common methods in the number class, we've got double value, float value, int value. So that should give you a hint here. So I'll just go ahead and start making mistakes from the beginning. So if we click on here, Java's type erasure replaces type with a number type bound. So the number class does not support the plus operator, so x plus y fails to compile. Then again, we don't have the .add class in there, or the .add method. So yeah, so that's going to fail to compile as well. So then we get over here and we've got Java type erasure replaces type with the number type bound. So x and y are numbers and the program can call double value on x and y to add their values as doubles. So then statement C, we've got average equals sum divided by 2.0. And we've got average equals sum dot double values, the method divided by 2.0. So I think we're going to go with this, but just to see what the, it's going to be here. So sum is a double, so the program can divide the sum by the 2.0. So over here, again, this comes down to this is the instance. It's not an instance of a number, it's an instance of a double. So that's not going to work. So you have to remember what you had originally set up sum to be. So sum was a double over here. So you can't use double value because that's the abstract, or that's for number. So then our last challenge activity is going to be, let's see, start. So complete the definition of public static. Public static generic method compare numbers as follows. And the type parameter sum type extends the number class. The return type is void. Compare numbers has two parameters named range 1 and range 2, both of type sum type. So this pretty much tells you everything you need to do right here. So here we have public static. So we're going to start off here. It's telling us that the type parameter sum type extends the numbers class. So we start with our brackets. Sum type extends number, and then we need our return type, which is void. And then we've got the function name or the method name compare numbers. And we've got two parameters, and they're both of sum type, sum type, range uno, and sum type, range dos. So that looks like it would be it. Watch me check it and miss. And that is correct. So the next one is the same. You're just having to define it here, so I'll let you do this on your own, but you're going to define a public static, and this is very prescriptive. I mean, it's asking you, saying just like before, the type parameter is item type, so this is the type we're going to be dealing with. The return type is string. Join two values. That's our function, our method name has two parameters, and these are the types. And then the function itself is going to, or the method itself is just going to return this. So that's what your return statement is. So note that this one we're not dealing with, we're not extending it here. So you don't have to worry about something like extends number, anything like that. But yeah. So anyway, go ahead and knock that out, and that will be it for our generic methods and type bounds. And we will continue on in our next lesson. So if you have any questions, feel free to reach out and ask me, and I'll be happy to answer. See you in the next video. Aloha.